So the first is about the Diamond Open Access journal, Philosophy and the Mind Sciences, that I'm running together with Sasha Fink, Jenny Wind, and Yingtong Lin. So please feel free to submit your manuscripts to Philosophy and the Mind Sciences. Second ad, there's a conference on models of consciousness happening at the end of September, beginning of October in Bamberg, organized by the Association for Mathematical Consciousness Science. And I'm one of the co-organizers. The main local organizer is Johannes Kleiner. We have a call for abstracts, and you can still submit your abstract until the end of June. All right, now for the talk. So I'm a huge fan of the series Black Mirror. And one thing that I find striking about this series is that that many episodes are about artificial consciousness, or that there are systems in the stories that are depicted as artificial consciousness, or at least it's suggested that they're actually conscious systems. And there's a huge variety of different artificial systems that are depicted in this way. And here's just a very narrow selection from the first and the season and from a more recent episode. So on the left-hand side, you see pictures from the Christmas special of the first season. And here at the top, you see a scene with a real character, real person, Matt Trent, played by John Hamm, and he's communicating with a simulated version of a conscious human being, and the simulation is running on this egg-shaped device. And on the second picture, you see a scene from the perspective, or from within the simulation that is running on that device. And you see a virtual avatar, which is a digital copy of one of the characters in that episode, Greta, played by Una Chaplin. And these virtual avatars are called cookies in the series. And it's very suggestive, or at least I interpret or view these as, or have the impression that they're supposed to be conscious artificial systems. And so the virtual avatar can interact with non-virtual characters. So you see the non-virtual environment from the point of view of the virtual environment. There's an interface to the non-virtual environment. And then at the bottom, there's a scene which takes place in a completely virtual environment. And there's a virtual avatar, virtual version of Matt Trent, but it's actually controlled by Matt Trent himself. So it's not a completely digital copy of this character, but it's a virtual avatar that is controlled by a non-virtual avatar from outside of the simulation. A bit similar to the way in which Neo in the Matrix, Neo as a real human being, controls the virtual avatar within the Matrix. Okay, and then on the right-hand side, this is a picture from a more recent episode, Beyond the Sea. And there you see a non-virtual avatar called a replica in this episode. So this is a humanoid robot, which is very similar to a real human being or real human body. And different characters can upload their conscious experience, as it were, to this replica. And as I said, so these virtual avatars or artificial systems are depicted in such a way that it seems that consciousness is ascribed to them. So in a sense, Black Mirror is very liberal when it comes to artificial consciousness. And I wonder if there are any constraints on consciousness in artificial systems such that we could say, well, it's maybe a bit less likely that this virtual avatar is conscious as compared to the likelihood of this replica being conscious. All right, so more specifically, I want to ask in this talk, is it plausible to assume that consciousness requires neuromorphic processing? And the claim that I want to put forward is that there's a form of neuromorphic processing that should be regarded as a constraint on consciousness in artificial systems. And the main aim of this talk is to clarify this claim. So what do I mean by neuromorphic processing? What type of constraint do I have in mind? And why do I think it's plausible? And just in brief, so the notion of neuromorphic processing I have in mind is very general. So the basic idea is that it's an embodied form of processing. There's at least a potential for an interaction between the system and a non-virtual body. And the constraint I have in mind is what I shall call a soft negative indicator. So I'm not saying that systems that don't display this form of neuromorphic processing are non-conscious, but just that it's less likely that they're conscious. And it's plausible because all known biological systems arguably fulfill this constraint, and even some possibly conscious artificial systems, but not all artificial systems. So it's an interesting constraint as well. Okay, so neuromorphic processing, we heard a lot about neuromorphic hardware yesterday. So Pascal and Herbert gave overviews of different forms of neuromorphic hardware and also more material-based approaches to computing. And Chiara in her keynote also made a connection to embodiment. So for embodied AI for robots, if I understood it correctly, neuromorphic hardware is especially promising. And actually, so the notion of neuromorphic processing I have in mind is somehow related to embodiment, albeit in a very general way. So what I have in mind is a neuromorphic causal flow. So one thing that is striking about neuromorphic processing in the brain of conscious organisms is that it's embodied, it's connected to a body. There's a direct causal interaction between the brain and the body, and between the brain and a non-virtual environment. Okay, so this is the general idea. What does a neuromorphic causal flow look like? So we have a causal interaction between the brain and the body. And if we contrast this with the causal flow in a computer simulation that is implemented using classical digital computing, so in a computer with a von Neumann architecture, Pascal explained very nicely what this means. Then it's different. So we have here states that encode the neural states of the simulated conscious human being and states that encode the bodily states. And these are encoded in the memory. And there's no direct causal interaction between them because it has to be mediated by processing in the central processing unit. So no direct causal interaction between states that encode brain and body or non-virtual environment. And in the sense, no neuromorphic causal flow. Okay, so a lot hinges on the term direct. And in the final part of the talk, I will try to clarify this a bit more with some examples. Okay, so this is the answer to the first part of the, to the first question. The form of neuromorphic processing I have in mind is a direct causal interaction between neural and bodily states. Okay, so in what sense should this be regarded as a constraint on consciousness? We can make a broad distinction between deterministic and probabilistic constraints. So deterministic constraint would be a necessary condition such that if a system lacks this, does not fulfill this condition, it's non-conscious. And as I said, we can contrast this with probabilistic constraints. I call them negative indicators. And here we can distinguish between hard negative indicators and soft negative indicators. So a hard negative indicator is a property or condition such that if a system lacks this property, it's probably non-conscious. And David Chalmers published a nice paper on the question whether large language models could be conscious last year. And there he suggests, well, if you want to argue that an existing or future large language model is conscious, you have to argue that there's a property X such that large language models or future AI systems have X or can have X. And if a system has X, it's probably conscious. And conversely, if you want to argue that a existing or future large language model is not conscious, you have to argue that there's a property or condition X such that large language models don't have this property, they do not fulfill X. And if a system fails to fulfill X, it's probably not conscious. And given the uncertainties surrounding consciousness and what conditions may or may not be required for consciousness, we can try to generalize this view a bit and make it a bit less demanding. And so this brings us to the idea of a soft negative indicator, which is a property or condition such that if a system lacks this property, this just provides a reason for lowering our credence that the system is conscious, where the credence that a system is conscious is a subjective probability that the system is conscious. So the idea is that we cannot conclude that it's probably not conscious if it doesn't have X, but we can say, well, it makes it a bit less likely that it's conscious. And of course, we can, this is not completely distinct from the hard negative indicators view, so we can regard this as a generalized version of the hard negative indicator view, in the sense that some soft negative indicators may just make it a bit less likely that a system is conscious if a system fails to display this indicator. And other negative indicators may be such that failure to display the indicator makes it a lot less likely that the system is conscious. Okay, but then you could also suggest that, and just want to give credit to Christian de Weert. So he has a forthcoming paper in which he makes a similar point and argues that we should not forget about reasons for regarding systems as non-conscious. Okay, and one could also suggest, well, we don't really know what is required for consciousness, but we can look what evidence there is for consciousness in different kinds of system, and we shouldn't regard any indicators of consciousness as constraints, but only as positive indicators, such that if a system lacks an indicator, this does not provide a reason to lower credence that the system is conscious. So the idea would be that we can have indicators that make it more likely that the system is conscious if it displays these indicators, but if a system does not display these indicators, that doesn't make it less likely. So of course, if a system displays only very few indicators, it's very unlikely that the system is conscious, but it's not that. Some of these should be regarded as requirements, or as at least candidates for requirements on consciousness. And a view like this is exemplified by a recent preprint that was published last year. So as a report on consciousness in AI by Patrick Botlin, Robert Long, and many other co-authors. And there they suggest that we can derive indicator properties from theories of consciousness, and properly interpreted, they can be applied to different artificially intelligent systems, different AI systems, and then we can assess the likelihood that a system is conscious by looking at how many indicators it displays. But we should not regard any indicator as a requirement on consciousness. So there are no constraints, no negative indicators according to this approach. Now, which view should we adopt? Or put differently, what kind of constraint should neuromorphic processing be, if any? When it comes to the first view, deterministic constraints, this runs the risk of under attribution of consciousness or false negatives. So we may erroneously believe that something is necessary for consciousness in an artificial system. And given the uncertainty there's about consciousness in general and about any candidates for necessary conditions for consciousness, it would probably be prudent to avoid under attributing consciousness, and we shouldn't rely too much on such deterministic constraints. Similar considerations apply to the hard negative indicators view. Maybe there are some indicators that are really strong candidates for necessary conditions, but in general, it's probably best to not presuppose that all negative indicators are strong negative indicators. And when it comes to the no constraints view, this might run the risk of over-attribution, leading to false positives if we just look at positive indicators for consciousness, but disregard candidates for negative indicators or constraints on consciousness. And so what I want to suggest is that the soft negative indicators view is in general the preferable view, because it's most flexible. So it can also be it can incorporate hard negative indicators because it doesn't specify that all negative indicators must be probability lowering in the same way. So some negative indicators may be weak constraints, or we might have fairly weak evidence for regarding them as requirements on consciousness, whereas other constraints may be strong candidates for necessary conditions, and so it's could be justifiable to regard them as hard negative indicators and say, okay, if a system lacks this property, it's probably non-conscious. And of course, we could also regard the no constraint view as an extreme or limit case of the soft negative indicator view, in which negative indicators are just a very little probability lowering. Okay, so that's why I suggest in general the soft negative indicator view is should be preferred, and in particular also when it comes to neuromorphic processing, because it's, as I will motivate in the final part, it's a plausible negative indicator, plausible constraint, but it's not an extremely strong negative indicator. Okay, so that's the answer to the second question. What type of constraint am I talking about? I'm talking about a soft negative indicator, which is such that if a system fails to display this indicator, if there's no neuromorphic processing in a system, then this makes it a bit less likely that the system is conscious. Okay, now what makes a constraint on consciousness in artificial systems plausible? I'm suggesting that it's plausible if it's entailed by different kinds of conscious system, and in particular by biological and non-biological systems. And here these should include human beings, other animals, and then also artificial systems that might be conscious, brains in bats, human beings with artificial brains. And so this may seem a bit strange. So it might seem that I'm conceding too much if I'm saying, okay, this should be, we should, it should be satisfied by human beings with artificial brains, because I'm presupposing that this form of artificial consciousness is possible. But the idea is not that I'm claiming that these forms of artificial consciousness are possible, but just if a constraint is satisfied not just by uncontroversially conscious systems, but also by some artificial systems that might be conscious, but not by all artificial systems, then it's an interesting constraint. And in particular, if you can show that a constraint is fulfilled by some but not all artificial systems, then it's more plausible as a constraint than a constraint that is not fulfilled by any artificial systems. Also, just to illustrate why this is useful, so David Chalmers suggests if we can establish that one digital system is conscious, then we know there's no general reason why digital systems cannot be conscious, and the floodgates will open. And what I'm suggesting is that neuromorphic processing, in the sense that I have in mind here, is a constraint that is fulfilled by some but not all digital systems, and that this might provide a way to keep the floodgates closed, while still conceding that there are some digital systems that might be conscious. Okay, and what digital systems does Chalmers have in mind? So here he's presenting his substitution argument, and in which the biological neurons of a conscious human being are gradually replaced by artificial neurons. And he's suggesting, well, there's good reason to believe that the resulting system is conscious, it's an artificial system. But if this artificial system is conscious, then it's also likely that many other artificial systems will be conscious. In particular, purely digital systems, virtual avatars in a computer simulation. Okay, so here's how he describes the thought experiment on which the argument is based. We can simulate your brain one cell at a time or one area at a time. We build a simulation of each cell and arrange for it to interact via receptors and effectors with neighboring biological cells. Eventually, a quarter of your brain will be simulated, then half, then 3/4. until the result is a fully simulated brain. Perhaps the simulation will be connected by effectors to the original physical body, or perhaps the body will be simulated too. Okay, now why should we believe that the end product, the complete simulation, is conscious? Well, if it's not conscious, then consciousness has to disappear at some point during the procedure, and this disappearance is either happens suddenly, or consciousness gradually fades away. And Chalmers suggests that both of these options are implausible, and so we have to conclude that the system will be conscious at the end of the procedure. Against the first option, he argues that this would be an extraordinary discontinuity, unlike any other that we find in nature. Just want to mention that there's a recent paper in Analysis which argues against this, because we find there are discontinuities in nature, there are dynamical systems that have bifurcations, sudden changes in system behavior. So this might not be completely plausible, this objection to the first option. And against the second option, Chalmers suggests because your neurons have been replaced by perfect simulations, your behavior will be completely normal. Throughout the process, you'll swear that you're fully conscious. You think it's normal when in fact it's fading away. So you think your conscious experience is normal when in fact it's fading away. This also seems quite bizarre. And there's a recent preprint that also argues against this objection, but for the sake of my argument, I can grant this all to Chalmers. I just want to highlight that it's not at all obvious that this argument, that Chalmers' argument goes through. And just as a further objection, general objection, so Chalmers suggests that we can build a simulation of each cell and arrange for it to interact via receptors and effectors with neighboring biological cells. And there's a nice paper by Rosa Cow in which she argues that this might not really work in practice, because no matter how many neurons and glia we replace, there will always remain significant biochemical residue, because the functionally important parts of the brain are inextricably bound up with the rest of the body. For example, the blood vessels carry causal influences to and from the rest of the body in ways that affect the inner functional organization of the brain, and not just its sensory inputs and behavioral outputs. Can we replace the blood vessels as well? Not without rejiggering the rest of the circulatory system and the body. So I'm just mentioning this to flag that I'm not entirely convinced of Chalmers' substitution argument. But for the sake of this argument, I can grant that it's possible to replace biological neurons in the brain of a conscious human being with artificial neurons, and that the result will be conscious. And because this also fulfills the constraint, so it's not a counterexample, but rather shows that even if such artificial systems are possible, even if it's possible to create an artificial brain in a human body, even in that case, you'll find some neuromorphic processing in the sense I have in mind here. Okay, so but one might wonder that this is not really, even if it's a constraint that is fulfilled by many by biological conscious organisms, and also by at least some conscious artificial systems, why should we regard it really as a constraint on consciousness? And so Johannes cited this idea in his talk yesterday that you could have a computer simulation of a rainstorm, but it will not make us wet. So there are certain properties or certain systems that can be simulated, but will then have very different properties, or will not have all the properties that are required for replication of the system. Okay, and to this point about the rainstorm, one could respond, well, if the simulation of the rainstorm is part of a sufficiently detailed computer simulation with virtual individuals, then we could say that the virtual individuals in the computer simulation will become wet. David Chalmers mentions this and credits Douglas Hofstadter with the idea. And he says Hofstadter's insight is that whether or not we recognize a simulated hurricane as a hurricane depends on our perspective. In particular, it depends on whether we're experiencing the simulated hurricane from inside or outside the simulation. And now, whether or not this is convincing with respect to hurricanes, I don't think the reply works with respect to consciousness. So if we replace being wet with being conscious, we'd have to say whether a simulated conscious agent is conscious or not depends on our perspective. In particular, it depends on whether we interact with it from inside or outside the simulation. But if there's a conscious being in a computer simulation, if there's a purely virtual agent within a computer simulation, and if it's conscious, and it's conscious regardless of whether we are considering it from within the computer simulation or from outside of it, from the point of view of the non-virtual world. And I think this idea can be connected to the idea of neuromorphic processing, to the idea that a brain engaged in, or the system engaged in neuromorphic processing, that this is in direct causal interaction with its body. So in principle, you could take a biological brain of a human being and put it into a vat, and the result would still be a conscious system. And you can also do that with an artificial brain. I mean, the vat would have to be a bit different. Don't want to destroy the artificial brain. And you could also put the artificial brain into a robot, and there would still be neuromorphic processing going on, and the result might be conscious. And now, at this point, someone like Chalmers might say, "Aha! Now you're actually opening the floodgates, because you're conceding that you could have a completely artificial conscious system, and so if you have a robot with an artificial silicon-based brain, then you can also simulate that on a computer, and there's no real difference between them." And so that this would suggest that the floodgates do open, and if you have one digital conscious system, then you can have many. But again, if we compare the computer simulation to the embodied artificial system, there's a difference that we cannot just take the part of the system that encodes the brain that is simulated and put it into the robot. So I want to suggest that this is kind of a litmus test for whether there's a direct causal, whether the system can directly causally interact with a body or a non-virtual environment, namely, can we in principle take the parts that encode the inner states of the system and connect them to a non-virtual robot or body in such a way that it controls the body. And this is possible for systems with a neuromorphic causal flow, I mean, at least in principle, but it's not possible for systems that are instantiated on a classical digital computer. Now, just for completeness, so yeah, in all these cases we have neuromorphic processing, but I'm not suggesting that all of these systems will be conscious. So just to be clear, I regard neuromorphic processing or neuromorphic causal flow only as a constraint, a soft negative indicator. So if a system does not fulfill this constraint, it's less likely that it's conscious, but that doesn't mean that the presence of this indicator makes it likely that the system is conscious. And now if we compare this to the cookie in this episode of Black Mirror, the virtual avatar is part of the computer simulation, and its states are encoded by the memory unit, so there's no neuromorphic causal flow. Whereas there is neuromorphic processing in the real person, and also in this case, I'm here at the bottom because there's a real person involved that is interacting with virtual avatar, controlling the virtual avatar. And there's also neuromorphic processing in the replica, but not in the virtual avatar. Okay, so to summarize, I'm suggesting that the possibility for a direct causal interaction between an artificial system and its body or non-virtual environment should be regarded as a soft negative indicator for consciousness. In other words, if the system cannot engage in direct causal interaction with its body or non-virtual environment, we should lower our credence that the system is conscious. Thank you very much for your attention.